Before moving on to the experiments, let us first describe the experimental setup. A container is supplied with water by a tap A. It is equipped with two outlets B and C. Outlet B is always free. The water it drains is collected in the sink, whose drain hole is blocked. Outlet C is initially blocked. It also has a supply outlet D. The flow rate of a pump E can be regulated by a voltage regulator F. The pump has a suction mouth G, and an exhaust mouth H. One end of a pipe I is connected to the suction mouth G. Initially, its other end is free. The pipe hangs in the sink. Subsequently, this end will be connected to the discharge outlet C. A pipe J connects the discharge outlet H to the opening D. Initially, the water level in the container is at the lowest point of the opening B. This level is referenced by the letter K. During the experiment, the water level in the container will increase. Let us consider that it is at level L at a given time. The flow rate discharged at B depends on the water height H, which is equal to the difference between levels L and K. The greater the water height H, the greater the flow rate discharge. This assembly allows us to make an analogy with the mechanisms that govern the temperature on the surface of the planet. It is enough to consider that the water in the system represents energy in reality. In this case, a water flow rate corresponds to a power. The height H is a measure of the temperature of the surface of the planet. The volume of water between levels K and L is a measure of the energy that the planet accumulates under its surface. The flow rate of tap A is representative of the power that reaches the surface of the planet from the sun. The outlet B is the only one that is free in the system. The flow rate at B corresponds to the power emitted by the surface of the planet towards the cosmos, whose role is played by the sink, which collects all the energy evacuated through opening B. The pump plays the role of greenhouse gases. Now let's move on to the small experiments. Let's start the first experiment where we simulate a situation without back radiation. This corresponds to Figure 1 in the accompanying document. Note that the pump is cut off. The only power source is the tap. It has been turned on. The water level rises in the container. Water drains into the sink. Initially, the feed flow is greater than the discharge flow. The water level rises. The higher the water level, the greater the discharge flow. Finally, the level stabilizes. At this point, the discharge flow is equal to the supply flow. Let's increase the feed rate. The level increases again until a new equilibrium is established. Let's turn off the tap. The water continues to drain. The water level is dropping. The discharge flow gradually decreases. It becomes zero when the water level reaches the bottom of the drain hole. Let's repeat the operation. The system is evolving towards a new equilibrium. Let us mark the level of equilibrium with a line. It will serve as a reference later. Now let's move on to the IPCC's incorrect interpretation of back radiation. The montage reflects Part B of Figure 3 in the accompanying document. The red circle somewhere between the planet and the cosmos is problematic. It is impossible to materialize it, and yet the pump's suction port must be connected somewhere. If left in the open air, a magic trick would be required to make the pump reject water after sucking in air. Let's go back to the video. For now, let's let the pump draw water from the sink. This is the only way to raise the water level in the container. The pump has been activated. It is re-injecting water into the container. The water level rises to a new equilibrium state. Let's increase the pump flow. The level increases again. Let's turn off the pump. The water level decreases and returns to the reference level. It has just been observed that a supplementary feed source impacts the water level. The problem is that this source does not represent back radiation at all. In reality, all we have done is introduce a second external source which acts as the main supply tap. Let us now turn to Panel C of Figure 3 of the accompanying document. It is the only one that correctly describes the influence of back radiation. Let's reactivate the pump. Let's connect the pump suction mouth to the correct place. Let's unplug the second drain hole and connect the pump suction port to it. The water level gradually returns to the reference level. Let's increase the pump flow. The water level does not change. You will notice that no matter how hard you activate the pump, the water level refuses to change, which means that in reality, the temperature does not change. This observation is not only valid for greenhouse gas-induced back radiation. This is also true for other causes of back radiation, which can be much more important than that due to greenhouse gases. They too have no influence on surface temperature. Generally speaking, it must be concluded that any energy that has been emitted by the Earth's surface, and which subsequently returns to it, has no influence on its surface temperature. This concludes the experiments.